I'm going to leave that in. All right. How's everybody going today? I'm off today, so I thought I'd do a little video, and I wanted to show you guys this antenna for your ham radios, those of you that are doing ham radios. I've got a radio here, and this radio is a directional, this antenna is a directional antenna. So as you point this, that's how that goes. Yeah, that sounds really intelligent, doesn't it? Anyway, so as you use this antenna, the direction is oriented horizontally from the elements. These are the elements here. And yes, they are in fact from a cheap $4 tape measure from Harbor Freight. So I don't feel too bad. It wasn't like I spent $28 on a Stanley or anything like that. But I will go through all of the parts that you will need in order to build one of these, and I'll go through the measurements, and you can build one for yourself. And they're great. Actually, this antenna works spectacularly, to be honest. Now, like I said, I probably got, as far as the parts included in this build, I probably have $26 into this. And that includes the tape measure, the PVC pipe. Hopefully you have duct tape laying around. That's what this is just duct tape. Your parts list, and I will probably have to I'll write this out and put it on the screen. But you're going to need 6 hose clamps that fit whatever size PVC you get. You can get smaller PVC if you want. You're going to need 2 X pieces and 1 T piece. You're going to need your PVC pipe here. This segment is 12.5 inches long from center to center. So this actually is about 11 inches, if I'm remembering right. I gotta look at my schematic. Yep, this piece is 11 inches long. This piece is 6 3/4 inches long. And this piece, it's however long you want your handle to be. I just used the rest of the piece that I got in order to use that. Now, your PVC pipe, this is not your PVC pipe. My wife is making faces at me. I can't help it. Your tape needs to be cut at specific lengths for each of the elements, okay? And we'll go through how to build it too. This element right here, we'll call this element number 1. Element number 1 needs to be a continuous piece, 35 1/8 inches. Now this is specifically for the 2-meter band. So you're going to be 144 out to, well, actually it's 135 all the way out to 150 something megahertz. All right. So this is going to be 35 1/8 inches. This actually is 2 separate elements, and you can see they're separated by 1 inch of distance in here. These are each 17 3/4 inches long. And it's important that you have these cut to length, and this needs to be an appropriate distance. It needs to be 1 inch apart, and these need to be centered up on your pieces here. The distance from element to element, and then your reflector elements, they all need to be distanced properly, or you will not get the kind of reception that you need to get. And I'll put a schematic up on there, and you'll be able to see it as an overlay. Please feel free to pause the video and take a screenshot if you want to. That is fine. And that way you can build your own. And then this last element here, element number 3, is a continuous piece as well. It is 41.5 inches long from end to end, 41.5 inches. And you can actually see my mark here. I'm hitting the chandelier. You can see my mark here where I actually show where the middle of those are, so that I know when I set this up and put it into the hose clamps that it was centered on my antenna mast, which is what this is. Now, if you build a 2-meter antenna like this, it will actually work for 70 centimeters as well, which is 440 megahertz out to like 500 megahertz, give or take. But instead of orienting the antenna like this horizontally, you're going to run it vertically like this. I don't know why. It's just the way that the radio wave works, the way that it hits the antenna, the way that it travels. This is 70 centimeters. This is 2 meters. But anyway, I'm going to flip this over, and I'm going to show specifically this little segment here in element 2. This is going to be your power source, and then these are going to be your reflectors that actually help reflect the radio frequency and direct it. All right, so you can see here, I have a small wire here. This wire is literally cheap speaker wire. I bought a roll of it a few years ago, and it's 16 gauge speaker wire. That segment there is maybe 3.5 to 4 inches long. You're going to strip the ends off there, and then you're going to take your tape measure and you're going to sand it down to the metal so that it's bare. And then you're going to take, this is going to be your jumper here. You're going to solder that to each side. And you can see my soldering job is pretty grody. I'm not super concerned about how it looks. I just want it to hold well. This cable here is RG58 coax. It's a 50 ohm coax cable. And you want to peel the end off, cut it and peel the end off. You're going to take all of the braided stuff and twist it up for one side, and then you're going to take the center piece and you're going to connect it to the other side, and you're going to solder those in as well. That way you're powering it with this, and you have your jumper cord there. That's how that should be set up. I wrapped my cable around the mast and brought it out onto the front side here, just because I didn't want my elements to fold over. This lets them lay a little bit more, I don't know, have a little more rigidity. You can actually reinforce these with like dowel rods or whatever, and that, I mean, you can literally make it so that you can put this outside and put it on a mast up pretty high, run a longer coax, and you could leave it out there in the weather. It's not gonna hurt it. I mean, it would degrade after a while, but you could leave it out there for the whole season if you wanted to. But this is a PL259 connector, and then I put a BNC on the end because of the cabling that I use for my radios, because you're going to connect this to the radio because this is your antenna. All right, this wire here is kind of overkill for this application, but it's what I had laying around. So you're going to take BNC, and this is actually quite difficult to do one-handed and on camera. And then, of course, take the antenna off the radio, set the radio there. And now that you all are seasick from trying to watch me do this, there we go. And there you go. Now you have it. The radio is connected to the antenna. And literally all you have to do is point the antenna in the direction you want to go and set it to the frequency that you want to run and start going, start communicating. All right, folks, I got a buddy of mine connected on the other end of things here. I can hear him trying to break through. Might take us a couple of tries here, but we're going to try and see if we can make contact. All right, had to switch frequencies. KC3EXU, this is KC3VPM. Do you copy?
KC3VPM, this is KC3EXU. I got you a solid 5.9. Go ahead. Copy 5.9. You are also 5.9. Really, really good clarity. Man, I like that VX6. I am actually using the VTech. So that's nice to hear that it's coming through clear. Yeah, Yeah, you're pretty much full quieting, just a little bit of background noise. You're metering at about an S3 on mine, but you're coming through solid, and I'm pointing my 2-meter Yagi antenna straight at your azimuth. Over. Copy that. Copy that. That's same here as well. I'm pointing it straight at you, and yeah, that's great, man. Thank you so much. I appreciate the help with this, and we'll see if it helps anybody up on the YouTube. KC3EXU. This is KC3VPM, and I'll be clear on your final. Absolutely, this is a great project for anyone to make, and it honestly costs less than $20. You can probably find everything around your house. I'll be clear on this frequency, and 7.3 KC3 VPM from KC3EXU. Copy that, 7.3.
So there you go. That is radio to radio with no repeater between us. If you don't know what a repeater is, generally it's a type of radio that copies your frequency. It like gathers your frequency, what you're saying, and it repeats it out. Generally, repeaters run much higher wattage than just a little handheld radio. This one's 5 watts. His was 5 watts. And we're about 15 miles away, 14 and a half, like 14.7, I think. This is great. I've actually been able to hit the repeater in Old Town, Maryland, which is over 50 miles away, with this setup. So it works. It really, really works. And like he said, he put his together. He had a couple of pieces that he didn't have to buy. That's why his was only 20. Thanks so much for tuning in, guys. Hit the like button, hit the subscribe, give me some comments in the comments below. Let me know what your thoughts are and what you want to see. Share the videos around, hit that like and the subscribe buttons. I appreciate it, guys. Stay prepared.